Hello everyone, welcome back to my channel. This is a video on DevOps interview questions part 3. So let's get started. Question number 1. Explain the differences between SaaS, PaaS and IaaS. The answer is SaaS stands for Software as a Service, PaaS stands for Platform as a Service, IaaS stands for Infrastructure as a Service. These are the three main types of cloud services, each offering different levels of control and flexibility. For SaaS, it is the most hands-off option. With SaaS, you usually use fully managed applications like Google Workspace or Salesforce, where everything is taken care of for you. As a DevOps engineer, you don't have to manage any infrastructure or app updates, just use the service. For PaaS, you get a platform to build and deploy apps without managing the underlying infrastructure, for example, Heroku or Google App Engine. As a DevOps engineer, you focus on managing the development, deployment pipeline, and scaling of apps while the platform handles the infrastructure and the runtime environment. For IaaS, it is the most flexible but also the most hands-on. With IaaS, like AWS EC2 or Azure VMs, you rent raw computing power, storage, and networking. You manage the operating system, middleware, and apps. This gives you full control over your infrastructure but requires more management, which is where DevOps comes in to automate provisioning, scaling, and monitoring. In short, SaaS is ready-to-use software, PaaS is platform for building apps, and IaaS is raw infrastructure to build anything. Question number 2. Describe the core services offered by AWS. First is compute, second is storage, third is networking. Fourth is databases, fifth is monitoring and management, sixth is identity and security. For compute, EC2, Elastic Compute Cloud, that is virtual servers to run applications. Second is Lambda, serverless computing to run code without managing servers. For storage, S3, EBS and EFS. S3 is simple storage service, that is scalable object storage for files. EBS stands for Elastic Block Store, persistent block storage for EC2 instances. EFS stands for Elastic File System, managed file storage for multiple EC2 instances. For networking, VPC and Route F53. VPC, Virtual Private Cloud, isolated network environment for your resources. Route 53 is managed DNS service for routing traffic. For databases, RDS and DynamoDB. RDS stands for Relational Database Service, that is managed SQL databases like MySQL, PostgreSQL, etc. For DynamoDB, it's managed NoSQL database. For monitoring and management, CloudWatch and CloudTrail. CloudWatch is monitoring and logging service. CloudTrail tracks API activity for auditing and compliance. For identity and security, IAM. It stands for Identity and Access Management. It manages users' access and permissions. The third question is, how do you ensure cost management in cloud environments? The answer is, to ensure cost management in cloud environments, I follow these practices. First is monitoring and alerts. Use tools like AWS Cost Explorer or CloudWatch to track usage and set budgets or alerts for unexpected costs. Second is right sizing resources. Regularly review and optimize the size of instances like EC2 to avoid over-provisioning. Third is auto-scaling. Implement auto-scaling to automatically adjust resources based on demand, avoiding overuse during the low traffic. Fourth is use of reserved instances. For long-term workloads, purchase reserved instances or saving plans for discounts. Fifth is tagging and cost allocation. Use resource tags to organize and track costs by projects, departments, or team. Sixth is leveraging spot instances. Use spot instances for non-critical tasks to reduce the costs. Question number 4 is, what is serverless architecture and what are its benefits? The answer is, serverless architecture means you don't have to manage the servers or infrastructure. Instead, you focus on writing the code and the cloud provider automatically handles scaling, resource provisioning, and maintenance. The benefits include cost efficiency. You pay only for the actual compute time used, not for the idle servers. Second is scalability. Automatically scales based on demand without manual intervention. Third is faster development. Developers can focus on writing the code, reducing the time spent on infrastructure management. Fourth is high availability. Built-in redundancy and fault tolerance by the cloud provider. Examples include AWS Lambda and Azure Functions. Serverless architecture is ideal for event-driven applications, microservices, and applications with variable or unpredictable traffic. The next question is explain the concept of regions and availability zones in cloud computing. The answer is in cloud computing, regions are large geographic areas that consist of multiple availability zones. Each region is isolated from others to ensure redundancy and fault tolerance. Now, what's the reason? A specific geographic location like US East or Europe West where cloud resources are hosted. What are availability zones? A data center or a cluster of data centers within a region designed to be isolated from failures in other availability zones. The benefits are high availability. Distributing resources across multiple availability zones ensures that even if one availability zone fails, your app remains up and running. The second is low latency. Choosing a region close to your users reduces the latency. Third is fault tolerance. Multi-availability zone deployment ensures business continuity during the disruptions. In short, regions are the broad locations and availability zones are the individual data centers within those regions, designed to provide reliability and scalability. The next question is what is Docker and how does it work? The answer is Docker is a platform that allows you to package and run applications in isolated environments called containers. Containers are lightweight, portable, and run consistently across different environments. Now, how does it work? Containers. Docker creates containers that bundle an application with all its dependencies like libraries, frameworks, etc., ensuring it runs the same way everywhere on your laptop, cloud, or server. Images. The blueprint for a container is a Docker image. You can think of it as a snapshot of your application and its environment. Docker engine. This is the runtime that runs and manages containers on your system. Docker Hub, a registry where you can find and share Docker images. Now, what are the benefits? Benefits include consistency. Developers and operations team can use the same environment, reducing issues when moving between the stages, that is dev, test, and prod. Second is portability. Containers can run on any system, whether it's your laptop, a cloud provider, or on-premises. Third is efficiency. Containers are lightweight compared to virtual machines, making them fast to start and requiring fewer resources. In short, Docker helps you create, deploy, and manage applications in a consistent and scalable way using containers. The next question is, explain the difference between a Docker image and a container. A Docker image is a lightweight read-only template that contains everything needed to run an application, the code, the libraries, and the dependencies. Whereas a Docker container is a running instance of that image. It's the actual execution environment where the app runs, and it's isolated from other containers and the host system. The key difference is, for a Docker image, it is a static blueprint for the app. For Docker container, it is a dynamic running instance of the image. In short, the image is the recipe and the container is the cooked dish that you can interact with and run. The next question is, what is Kubernetes and what problem does it solve? The answer is, Kubernetes is an open source platform that automates the deployment, scaling, and management of containerized applications. It helps you manage clusters of containers, ensuring they run smoothly across multiple machines or environments. The problem it solves. First is container orchestration. It manages and schedules containers across multiple servers, ensuring they are running efficiently. Second is scaling. Automatically scales application up and down based on demand. Third is high availability. It ensures your applications stay up and running even if parts of your infrastructure fails. Fourth is load balancing. It distributes traffic evenly across containers to prevent overload. Fifth is self-healing. It restarts or replaces containers if they fail. In short, Kubernetes simplifies managing complex containerized applications by automatic deployment, scaling, and maintenance tasks. The next question is, how do you manage secrets in a Kubernetes cluster? The answer is, to manage secrets in a Kubernetes cluster, you use Kubernetes secrets. These are objects that store sensitive data like passwords, API keys, and certificates in an encrypted form. The key practices for managing the secrets are: Kubernetes secrets. Store secrets in the cluster as base 64 encoded values. You can reference them in your application pods, that is environment variables or volumes. Second is encryption at rest. Enable encryption of secrets in Kubernetes to ensure they are stored securely on disk. Third is access control. Use RBAC, role-based access control, to control who can access or modify secrets in the cluster. Fourth is external secret management. For enhanced security, you can integrate Kubernetes with external secret management tools like HashiCorp Vault or AWS Secrets Manager. In short, Kubernetes provides built-in secrets management, but integrating an external tool and enforcing strong access controls ensures that the secrets stay secure. Question number 10. Describe the architecture of a Kubernetes cluster. A Kubernetes cluster consists of two main components, the control plane and the worker nodes. For a control plane, it manages the cluster and makes the global decisions like scheduling, scaling, and maintaining the desired state. It includes API server, the main entry point of managing the cluster, then controller manager, ensuring the desired state of the cluster is maintained, then scheduler, it assigns the pods to worker nodes based on resource availability, then etcd, it stores all the cluster data like all configurations and state. For worker nodes, these run the actual applications and services. Each worker node has kubelet that ensures containers are running in the pod and are healthy, kubeproxy that manages networking and load balancing for services within the node, container runtime that runs the containers. In short, the control plane manages and controls the cluster, whereas the worker nodes run the application workloads and containers. This architecture enables Kubernetes to automate the deploying, scaling, and management of applications across multiple nodes efficiently. Now, question number 11. What are some common monitoring tools that you have used? The answer is, here are some common monitoring tools that I have used. Prometheus, a powerful open source monitoring tool for collecting and querying metrics, often used with Kubernetes for real-time monitoring. Second is Grafana, used alongside Prometheus for visualizing metrics in a customizable dashboard. Third is ELK Stack, that is Elasticsearch, Logstash, and Kibana, a popular logging and monitoring stack to collect, analyze, and visualize logs. Fourth is Nagios, a widely used monitoring tool for infrastructure, alerting when systems or services go down. Fifth is Datadog, a cloud-based monitoring service that provides real-time insights into infrastructure, applications, and logs. Sixth is New Relic, provides an application performance monitoring and real-time analytics for full-stack visibility. These tools help in tracking system performance, detecting issues early, and ensuring high availability and reliability of services. Question number 12. How do you set up alerts for system performance issues? The answer is, to set up alerts for system performance issues, I follow these steps. First is identify key metrics. Monitor critical metrics like CPU usage, memory, disk space, response times, and error states. Second is use monitoring tools. Leverage tools like Prometheus with Alert Manager, Datadog, or Grafana to collect metrics from systems or containers. Third is define the thresholds. Set the thresholds for these metrics. For example, CPU greater than 80%, memory greater than 90% that indicate potential issues. Fourth is create alerts. Configuring alerts to trigger when thresholds are crossed. Use tools like Slack, email, or SMS or notification. Fifth is test and tweak. Regularly test and fine-tune the alerts to avoid false positives and ensure they capture meaningful issues. In short, I set up proactive monitoring with thresholds to get real-time alerts on system performance and take immediate action when necessary. Question number 13. Explain the ELK stack and its components. The answer is, the ELK stack is a powerful set of tools for searching, analyzing, and visualizing log data in real time. It consists of three main components: Elasticsearch, Logstash, Kibana. Elasticsearch is a distributed search and analytics engine that stores and indexes log data for fast retrieval. Logstash is a data processing pipeline that collects, transforms, and forwards logs from various sources into Elasticsearch. Kibana is a visualization tool that lets you create dashboards and analyze the log data stored in Elasticsearch. In short, Elasticsearch stores and indexes logs, Logstash processes and forwards the logs, Kibana visualizes and analyzes the logs. The ELK stack helps monitor, troubleshoot, and gain insights from the system logs efficiently, making it a popular choice for centralized logging and monitoring. Question number 14. What is log aggregation and why is it important? Log aggregation is the process of collecting, centralizing, and storing log data from multiple sources like servers, applications, and services into a single system for easy access and analysis. Now, why it's important? First point is centralized monitoring. It consolidates logs from various systems into one place, making it easier to monitor and troubleshoot. The second point being faster troubleshooting. It helps quickly identify and fix bugs, issues by providing a unified view of logs. Third is scalability. As your system grows, log aggregation ensures that you can manage large volumes of log data efficiently. Fourth being security and compliance. Centralized logs help with auditing and tracking access, making it easier to meet security and compliance requirements. In short, log aggregation improves visibility, simplifies monitoring, and enhances the ability to detect and resolve issues across complex environments. Question number 15 is, how do you approach troubleshooting a performance issue? To troubleshoot a performance issue, I follow these steps. I identify the problem, that is the first step. Gather details from users or logs to understand the symptoms. For example, slow response times or high CPU usage. The second is monitor system metrics. Use tools like Prometheus, Grafana, or Datadog to check CPU, memory, disk, and network usage. Third is check the logs. Analyze logs using ELK stack or other log management tools to identify errors or unusual patterns. Fourth is isolate the root cause. Narrow down the issue, whether it's infrastructure, application code, or external dependencies like databases or APIs. Fifth is test and optimize. Once the cause is identified, apply fixes like scaling resources, optimizing code, or adjusting the configurations, and test the performance improvements. Sixth is implement monitoring. Set up continuous monitoring and alerts to proactively detect future performance issues. In short, I take a systematic approach, identify, monitor, analyze, fix, and prevent using the right tools and metrics to ensure optimal performance. I hope this video will be helpful in your DevOps Engineer interview preparation. Please subscribe to my channel, and if you found my video helpful, do like it and share it with others who might need this video. Thanks a lot.